Well, today's the day that we get to learn how to evaluate a definite integral, and we're going to use an example to kind of see what the formula is. If we have a position equation, and if I ask you for the displacement from 0 to 2, you would say, well, take the position at 2 and kind of where I end minus where I start, and that would be my displacement, right? So S of 2, if I plug that in, that would give me 9. S of 0, that would give me 1. So I get a displacement of 8. Now I think that we'll all agree that the derivative of position is velocity. So if I wanted to find the equation for the velocity at any time, I would just take the derivative of this position, which is 4t. Now let's graph that for a second. If we were to graph 4t, the y-intercept would be 0. I'd go make sure I counted right, up 4 over 1, 1, 2, 3, 4 over 1, etc. I could draw that line. Now the question asks me, find the area under the curve from 0 to 2, because what we've been doing for the last couple days is we've been finding the area under the curve. Sorry, straight lines are very difficult for me. We're finding this area under the curve, and we've learned that what that is that that's the integral of, if I wanted to write it, I would really say, well, it would be that, correct? The integral from 0 to 2 of velocity. If my curve is 4t, then that's what I would be finding. Now let's see what this actually is. It's a triangle, so I'd have 1/2. The base is 2. The height would be the value of this last point, which is 8. And looky there, what do we get? We also get 8. Interesting, interesting. So in a sense, if this is the same thing, I could say that 0 to 2 of v of t dt, I got the same thing as I did when I got s of 2 minus s of 0, correct? So I could say that a to b of velocity is going to be the position, didn't need that last parentheses there, is going to be position, the change, let me put a's and b's, I'll get it together in a second, b minus s sub a. And that's, we're using velocity kind of show the formula, because with the f's it kind of doesn't make, it's kind of hard to understand. So I want you to see it in this way. If I want to evaluate a definite integral, what I'm going to do with this function here, now I put v of t, of course I could have put 4t there, dt, that would be the velocity. But what this is the antiderivative or the integral, okay? And so I'm going to take the integral of this function here, I'm going to evaluate it at the top bound minus the bottom bound, evaluate at the bottom bound, and that's going to be my answer. So here it is written formally, and notice it's really written two different ways, because I just want you to be aware of it two different ways. A lot of times you see it with this big F, but they have to make the statement. If they do it this way, they're basically saying that big F is the antiderivative of little f. And that's what this says, right? But I also write it like this, saying, hey, this guy is some derivative of whom? Well, of f. But the trouble with writing it this way, a lot of times people go, well, it doesn't say that it's the derivative. Well, it is the derivative of somebody, but it doesn't have to have that notation as, oh, it's the derivative. So I just want you to see it two different ways. Now let's look on how we're going to actually solve. So here's some observations. Again, provided you can find the antiderivative of this thing, which is saying the same thing as f prime and you finding f, same thing, then you now have a way of being able to evaluate a definite integral without having to use the limit of a sum. You don't have to do it the long way. If it's not something you can do with geometry, then you have a way to do it. And there's a certain notation that you're going to use, but when we get to the example, I'll talk about that notation. So let's actually do one and see what we got. Okay. So with example 1, now notice I'm not using a calculator because you've got to be able to evaluate these without a calculator. So I'm taking the definite integral from 1 to 2 of x squared minus 3. Now again, I hope you understand or have an understanding of what you are finding. And we'll look at the graph after we get the answer and see if that makes sense. But as far as the notation, you are going to take the antiderivative. Now for this first example, I'm gonna put the plus c in there for you to see something. So here we go. The antiderivative of x squared is 1/3 x cubed minus 3x. Now let's say I put the plus c in there. I'll put it in. Now here's the notation. I'm gonna evaluate that from 1 to 2. Now remember, it's top bound minus the bottom bound. So if I plugged in 2 for x, and I think you're okay with me kind of doing that in my head, I hope. So I'm plugging in 2 in. 2 cubed is 8, so I have 8/3 minus 2 times 3 is 6 plus c. I would have that. That's the antiderivative of 2 minus, now let's do the antiderivative at 1. That would be 1/3 minus 3 plus c. Correct? And so what does that give me? Well, what do you notice about the c's? For one thing, if I have, well, let me just write it all out. I would have 8/3 minus 6 plus c minus 1/3 plus 3, be careful there, this minus, notice the parentheses, minus c. What happens to the c's? They cancel. And what happens every time? They're going to cancel. So when you're doing definite integration, in every other example, I will never put the plus c. That was for indefinite. For definite integration, you do not have to worry about the plus c because it wouldn't matter what it is. Now to finish this one up, I just have to, of course, do the math here. So 8/3 minus 1/3, that is 7/3. And then I have a negative 6 plus 3, that's a minus 3, which I'll make that 9/3, and I get an answer of negative 2/3. Now, does that answer make sense? Well, not that you have to draw this every time, but I want you to be clear. If I were to draw x squared minus 3, that graph does this, it does this, over 2, up 1, it'd be about there. So this graph looks like this. Now what is that integral finding? The integral is finding the area under the curve, so from 1 to 2. Now obviously I have a little bit of area above, I'll make it a little bit bigger, and some area below. Does it make sense that my answer is negative? Yes, because do you see that I have more area below the x-axis than I do above the x-axis? So again, just because I get a negative number doesn't mean that all of my area is below the x-axis, but between 1 and 2, I have more area under the curve than I do over it. More area under the x-axis than I have over the x-axis. Okay, so let's practice some more with the algebra here. So the next one, well, it probably would make sense to rewrite that as 3x to the 1/2 dx. Now also remember your properties. With your properties, and I'll show you what I mean by that. As I integrate, if I increase the power by 1, that would be x to the 3/2. And then when I multiply by 2/3, are you with me that that would give me 2? So I'm going to take this to the, and then evaluate from 1 to 4. Now when I set properties, this is something, and again, this is a preference thing, but I like to do this sometimes, a lot of times really. If I have a constant, especially if that constant is a fraction, I can pull it out of the, I could have pulled this 3 out from the beginning, or I kind of use it with the integration and then just pull out this constant. That's going to be the same thing as 2 times x to the 3/2 evaluated from 1 to 4. To me, it just makes the number smaller. Again, especially if it's a fraction, I'm not having to deal with that fraction all the way through the problem. It's just at the very end. So I like to do that. So I would have 2. Now, what do? Remember, this is f of 4 minus f of 1. So when I plug in 4 into here, 4 to the 3/2 is going to be, let me write it out. I'm doing a lot in my head and this is the first time, so let me do it like that. Obviously, you don't have to write all these steps. But 4 to the 3/2, square root of 4 is 2. 2 to the 3rd is 8. And then, of course, 1 to the anything is there. And I get, for an answer, that integral would be equal to 14. Now, one last time, why don't you draw what that is representing? And it should make complete sense because you know a square root looks like this. And I would be evaluating from 1 to 4. I'd be finding the area of that weirdly shaped thing, and that would be 14. All right, let's try this next one. Now this guy's a little weird. Okay, the absolute value, the picture is going to be a huge help on this one. Think about what this guy looks like. Because with absolute values, you're going to have to do one of two things. You're going to have to rewrite it as a piecewise function, or you're going to have to do it kind of graphically. So I want to be clear, I like the graphical method. Remember, where is my sharp turn? You get that by setting what's inside the absolute value equal to 0. So I know you can solve that and you get 1/2. That means this graph, I'll make it really big, it does something, that would be where my V is, and it's going up, so that graph is doing something like that. And I'm evaluating from 0 to 2. So really what I need to do is I need to find the area of those two triangles. People, this mechanical stuff is going to be on multiple choice. Personally, yeah, do I know how to do it with integrals? Absolutely. But if, even though I do, would I choose to do it that way? No. If you have geometry, I would do this geometrically. I'd say, oh, let's not make this harder than it is. I'm going to do it with geometry. Could I figure out what y value this is? Well, sure. I plug in 0 for x and I get 1 for y. Could I figure out what this y value is way up here? Sure. Put in 2 for x and I get 3 for y. So if it were me, I would know that that area is going to be equal to 1/2, a base of 1/2, and a height of 1. That was the area of this first triangle right here, plus the area of this triangle, which would be 1/2. Now let's be careful. If I have 1/2 to 2, what's that space there? That would be, it goes 0.5 to 2, that would be 3/2. I'm doing this in fractions for some reason. Times, we said that height was 3. So what do I end up with? I end up with 1/4 plus 9/4, which is 10 over 4, or in other words, 5 halves, or 2.5. So I want to be very clear that if I were trying to get the number, then that's what I would do. Now, sometimes if a multiple choice question, they wouldn't actually have you find the number, but they would say something like, this integral would be the same as what? And they wouldn't actually find the number, but you would have to write two integrals. So I do want to write that out so that you have both ways. Do you notice that if I wanted to write that integral, what we really did is we broke it up into two integrals. We broke it up from 0 to 1/2. Now, what would be the equation of that line right there? Well, that line, you can tell that the slope is negative. You have to remember that the absolute value would change the sign of everything in the absolute value. So that line would be 1 minus 2x. And then we took the integral from 1/2 to 2. And this line has an equation of just the 2x minus 1 dx. So sometimes they ask you for that part. And I'm just for the sake of explanation, I am going to work this out. I just want you to see that I could have done it this way from the beginning. I would get the same thing, 0 to 1/2. And then this guy is just x squared minus x from 1/2 to 2. It's just a lot more, I have to be a little careful there. If I plug in 1/2, that would be 1/2 minus 1/4. Now, when I plug in 0, notice I get 0. That's not always true, but it is in this one. Plus, now let me do f of 2 here. So that would be 4 minus 2 minus, now plug in the 1/2. Now, believe it or not, if I did all that math, I would actually get the same thing. I would actually get the 5 halves. And so I could certainly do that two ways. It depends what the question is asking you for, is as to how you want to do it. But you kind of have to understand both. All right, one last one with trig. I can throw some trig in there. That's not a problem. Try that one. I'm going to integrate and get 2x minus, let's see, the integral of negative cosecant squared is actually cotangent of x. And I'm going to evaluate that from pi over 4 to pi over 2. So let's write this one out. So I have 2 times pi over 2 plus the cotangent of pi over 2. That would be the first one, minus parentheses 2 times pi over 4 plus the cotangent of pi over 4. So you just have to watch that when you're evaluating. If you have more than one thing, stick that parentheses around there and make sure that you're remembering to distribute that negative. So what does this end up being? Let's see here. I've got those 2's cancel, so I have pi plus, okay, the cotangent of pi over 2. That's 0, 1. Remember, cotangent is cosine over sine. So the cotangent of pi over 2 is 0. I'll go ahead and write it. Minus pi over 2. And I'll go ahead and distribute that negative. The cotangent of pi over 4, remember the pi over 4s are the easy ones. Those are 1s. So that would be minus 1. And so what does my final answer become? Well, pi minus pi over 2 is pi over 2 minus 1. And there would be my final answer. So that's how you're going to evaluate definite integrals on a non-calculator part. You're going to be using that. Now, in your homework, notice the next one says it says you can use a calculator. So I want to show you the calculator part, not so that you can cheat and do your homework on the calculator, because if you are doing that, you are crazy. But You can certainly check that way. And you need to know that if your test has a calculator part, remember how Math 8 was your best friend? Well, you're going to have another one. So it says, let's write these things out first, and then we will get our calculator. It says a particle moves along the x-axis, so its velocity at any time is given by that function. Now, I'm not saying you couldn't do this by hand. You could. This is not a difficult one. But again, if you have a calculator and you want to evaluate a definite integral, people use the dadgum calculator. So what would you need to do? So on letter A, we learned these formulas last unit. The displacement, and look at B, find the total distance traveled. What would be the equation for that? And here's another thing with free response. If the function is named, people use the name. Don't recopy the whole equation, because if you forget one little negative or you forget to write a squared, you won't get credit. So notice how I'm going to write this on my paper. You've got to have these formulas memorized. Remember that displacement is the integral of velocity. So literally on my paper, I would write it like that. I'm leaving some space when I pull up this calculator here. Whereas the total distance traveled from 0 to 2 is going to be, sorry, that integral drives me nuts. Distance traveled is going to be from 0 to 2 of the absolute value of velocity. So on my paper, that is all I would write. Now let's see how I can get this stuff on the calculator. So let's go ahead in your y equals, let me clear all this stuff out. In your y equals, let's put the equation. So I'm going to put that velocity equation. I'm just clearing out all this stuff. Now I say just like it looks on your paper, I'm going to do x's instead of t's. But other than that, I'm going to type it in because a lot of times you want to see the graph or whatever. I could do this on my home screen, but I like typing it into y1 because I never know when I'm going to want to evaluate or something. So I like to put it in y1. So I'm just double checking because I'd hate to miss it because I typed it in wrong. So I have that equation. On my home screen, remember, Math 8 was your friend, now Math 9 is also. For integrals, Math 9 is your friend. And there it is. People, it looks just like your paper. I'm going to put 0 to 2. Now, obviously, if I hadn't typed the equation into y1, I could type it in right there. But since I've already typed it in y1, I'm going to hit alpha, trace. I'm going to put in y1. I'm evaluating, again, my variable is x, and I hit enter, and sweet heavens, it gives me the answer. I'm just going to put equals -2. So my displacement is -2. Now, what does that negative mean? It means from the time he started at 0 and 2, he ended up being 2 to the left as to where he was originally. So that's what that negative makes sense. Now, if I want to do total distance traveled, then I'm going to do Math 9 again. I'm going from 0 to 2, but I want to put in absolute values. You can find that different ways. Honestly, I always forget where it is under, I think it's under Math somewhere. I have to look always. There it is, Math Num. So to be honest with you, I always go to, I find it with second catalog. Catalog pulls up every operation on your calculator in alphabetical order. So when I hit catalog, absolute value comes up first. So I tend to do it that way. And then I'm going to put y1 dx, and I will hit enter. I will go to 3 decimal places if it is not pretty. And so I get 6.831. And there you go. That's how you do integration, both algebraically and really graphically as well. If you need to draw a picture, you can do it with geometry, and you can use a calculator. So really and truly on your homework, I don't want you to use a calculator until about number 14. Can you use a calculator to check? Yes. But again, if you're using your calculator to do this, I'm going to be looking that you have work there and on the first 13. So make sure that you are have the algebraic steps. All right. Peace out. And now you know the FTC, the fundamental theorem of calculus. See ya.